Okay, Giancoli, chapter 14, example 6. We're going to make some ice. So what we have is we have some water that's at 20 degrees Celsius. Some water that's 20 degrees Celsius. Its initial temperature. We then have to cool it down to 0. And then we have to do a phase transition at 0. And then we cool down the ice even further to minus 12 degrees. So that's what we've got to do. So we have to figure out how much energy we need to cool it down to 0. We have to then do our latent heat of fusion, how much heat we have to take out, and then we have to take it from 0 to 12 with ice, free cooling the ice. So things we'll need. We'll need a specific heat of water. Got it. We'll need to know our specific heat of ice. It's not the same as water. Notice, when it's solid, it has different specific heat. And we also have our latent heat of fusion, which we're going to reverse, is 333 kilojoules per kilogram, or joules per gram, I guess we have to say. And what do we have? We got 1.5 kilograms of water. So let's figure out, first, taking the water down from 20 degrees to 0. Take it down to freezing point. Well, that's going to be Q. The heat there for that part is going to be the mass of the water times the specific heat of the water times the temperature change, which is going to be T final. Well, we reverse it, right? We want to know how much we're taking out. T final minus T initial. Got that backwards. Well, that's going to give us a negative number. That's how much heat we have to take out. So we'll remember, why don't we write it as T initial minus T final? That's the heat we have to take out. So let's figure that out first. So my mass of water, 1.5 kilograms. I'm not sure if you can see this. 1.5 kilogram. Specific heat of water, 4186. T final minus the T initial minus T final is 20. So we find that we get 125,580 joules. That's how much heat we have. So what are the units of this is in kilograms? This is joules per kilogram degrees C, and this is going to be degrees C. So degrees C cancels kilograms, so we get joules, and we definitely don't get 6 sig figs. So let's say we get 2 sig figs. So we were going to round to there. So this is a 5 or greater. Yes, it is. So we're going to go 130 kilojoules. 1, 2, 3. Okay, so how about from freezing the water? I have to calculate that. Freezing the water, which is at 0. We just need to do a phase transition. And remember, the heat for that phase transition is just the mass times the latent heat of fusion. Well, remember, well, there's no delta T because this is all has to occur at 0. So my mass is going to be the 1.5 kilograms again. And the latent heat of fusion, there it is, 333 kilojoules per kilogram. Okay, that's going to be nice and easy if we're going to keep it in kilojoules. And that is going to be 1.5 times 333. Gives me 499.5 joules, kilojoules, I should say, kilojoules, remember. And let's just give ourselves 2 sig figs for this, so it's going to be 500 kilojoules for that part. And let's add that to the previous one. And then we're going to cool the ice. We have to cool the ice down to minus 12 degrees. So how much heat do we have to take out? That's going to be the mass of the ice, which happens to be the same as the mass of the water, times specific heat of the ice. That's the one we got here. Times the change in temperature. Well, we started at 0, and then we subtract negative 12. So it's 0 minus 12 degrees. Oh, that's Celsius. That's Celsius. Got to be careful, and let's just do that. So mass of the water, that's going to be 1.5 kilograms again. Specific heat, there it is, 2100 times 12. So that is 37,800. Now that's in joules, so it's going to be 37.8 kilojoules. Oh my gosh, let's give myself 2 sig figs. 38 kilojoules for that part. So when we add them all up, Q total is the sum of all the parts from before. So we add this plus the 38. We get we get 164 kilojoules. That can't be right. I've done something wrong. We've got 130 kilojoules, 500 kilojoules, and 38 kilojoules. that makes more sense. Excuse me, 668, let's call it 670 kilojoules is the how much energy we have to take out of our ice.